In this next video, let's take a look at areas of shaded regions and total area of composites. Example 1 says find the area of the shaded region below. Okay, so what we're looking at here is a really large circle with two smaller circles inside. And so if I want to find just the shaded region, let's find the area of this large circle, and then we'll subtract out the two areas of the smaller circles. All right, so here's what we're going to do. We're going to find the area of the large, and we're going to subtract the area of the, we'll call that the medium, and the area of the small, and that will give me the shaded. All right, so the area of the large, well, I have no idea, but let's go ahead and start putting some numbers on here. If I know that this piece is 10, that means this piece is also 10. And if this piece is 3, then this piece is also 3. These are just radius, and radius are congruent. So the whole diameter of this large circle would be 10 plus 10 plus 3 plus 3. So that would be 26. So that's the diameter. The area formula is pi r squared, so I need the radius. If my diameter is 26, so let me just make a little note, diameter equals 26, the radius is half of that. So this is pi times 13 squared. All right, and so now let's subtract off the area of the medium. That's just pi times, well, the radius of the medium is just 10, and the radius of the small is just 3. And so that's just going to be pi times 3 squared. All right, and so let's see. 13 squared is 169. This is 169 pi minus 100 pi minus 9 pi. So 169 minus 100 would be 69 pi, minus 9 would be 60 pi. So my exact answer would be 60 pi, and this is meters squared because we're talking about area. If we wanted to write a decimal approximation, that would be about 188.5. In example 2, what we've got here is find the area of the shaded. So the shaded is all these little pieces around the circles. So first, let's find the area of this large square, and then we will subtract off the area of these 4 circles. And so that's our plan. We're going to find the area of the square, and then we're going to subtract the area of the circles. Okay, so just like we did in that first example, let's find a side length. Okay, so we're given radius. These are each 4, right? And so I know from here to here's 4, from here to here's 4. So I know one side length, if I added these 4's up, 4 plus 4 plus 4 plus 4 is 16. So I know that this square has side lengths of 16. Okay, so area of a square is just length times width, or side squared. So this is going to be 16 times 16. And if we want to find the area of a circle, well, that's pi r squared. And so our radius is 4, and we have 4 of them. So I'm going to say 4 times pi times 4 squared. Okay, so now let's take this to our calculator. So 16 squared is 256. And let's see, we have 4 squared is 16 times 4 is 64. So that's 64 pi. I could leave it like this. This would be an exact answer. Or I can approximate and get about 54.9 feet squared. In example 3, it says find the area of the shaded region below. All right, so we want to just find this little piece right here. And that's going to be the difference in this large circle and the small circle. All right, so that's our plan. Area of the large minus area of the small will give us the shaded. Okay, so first thing we have to do, pi r squared. We've got to find the radius. This 40 represents the diameter of this large circle. That means my radius of this circle would be 20. So this is pi times 20 squared. And the area of the small circle has a radius of 15. So pi times 15 squared. So 20 squared we know is 400. So this is 400 pi. And 15 squared, I believe that's 225. And 400 minus 225 is 175 pi. That would be an exact answer. And this, of course, would be meters squared. Or if I wanted to find a decimal approximate, that is approximately 549.8 meters squared. Oops. Let's take a look at example 4. Find the area of the shaded region below. Okay, so we have a trapezoid this time. If I want to find the area of the shaded, let's find the area of the circle, and then we'll subtract out the area of the trapezoid. So that's the plan. Area of the circle minus area of the trapezoid. And that'll give me the shaded. Okay, so pi r squared minus the area of the trapezoid. We add the bases, so base 1 plus base 2. The bases are parallel. So base 1 plus base 2 divided by 2 times the height. The height is perpendicular to the base, and so that's the 3 here. All right, and so that equals the shaded. All right, so we can see that the diameter of the circle is 12. That means the radius is going to be 6. So this is pi times 6 squared. All right, for the trapezoid, we have one base that is 8, one base that is 12, and the height is 3. So we have 8 plus 12 divided by 2 times 3. What we're doing is we're averaging the bases, adding the two sides and dividing by 2. That'll give us the average base. Okay, let's take this to a calculator. So let's see, we have 36 pi. 8 and 12 is 20, divided by 2 is 10. 10 times 3 is 30. And so we have 36 pi minus 30. That would be an exact answer. And this, we don't have any units, so I'll just put units squared. But if I wanted to get a decimal approximation, take it to my calculator real quick. 36 pi minus 30 is approximately 83.1 units squared. In example 5, find the total area. Oh, this is a nice easy one because what we have here is just two rectangles. We've got this rectangle on the top, and you can divide it other ways, but it just seems natural to divide it this way. Let's just add the areas together. So the area of the large rectangle plus the area of the small rectangle is equal to the total. All right, so area of a rectangle is just a length times width, so this is 5 times 14. Area of the small rectangle. Okay, so let's take a look. We know that this whole side length is 10. This piece is 5. Well, then this piece also has to be 5. Okay, so now the side lengths on this small rectangle are going to be 5 times 8. Okay, let's add these together. So 5 times 14, I believe that is 70. 5 times 8 is 40, and so that's 110, and this is meters squared. Last example, example 6, find the total area. Okay, so I see three shapes. I have the rectangle on the top, triangle over here, and another rectangle on the bottom. Let's just find the area of the big rectangle plus the area of the small plus the area of the triangle. And that'll give me my total. All right, so the area of the big rectangle, I'm calling this my big rectangle, 4 times 3. Area of the small rectangle, that's this guy here. And looks like I have 3 and 2, so that's 3 times 2. And the area of my triangle, that's 1/2 base times height. And let's see, my base is 2, my height is 3. So this is plus 1/2, 2 times 3. Okay, let's add these up. So I have 12 plus 6 plus 2 times 3 is 6, and half of that is 3. 18, 19, 20, 21 centimeters squared. And that's my final answer.